Good morning, everyone. Thank you for that fantastic introduction, and thanks everyone for coming to this talk today. We're going to talk about what a lot of people are talking about these days, generative AI. And for me, from my perspective, I'm talking about full stack AI engineering, which for me goes from the LLM down into the software stack and how we actually build applications that work with LLMs. So everything starts in the beginning with a prompt. This is one of my favorite prompts to try out with any new LLM that I'm trying out. How does it deal with being asked to talk like Yoda? This is ChatGPT 4.0 that I've got this little conversation going on with, and it compliantly plays along. It's like, okay, talk like Yoda. I can talk like Yoda. Talk like Yoda you wish. Storm with the force your request is. Fantastic. So far, we've already established how LLMs behave. You give them some instructions. They're happy to follow those instructions. They're very compliant. They try to play along with whatever you set them up to do. This is the essence of all prompt engineering. Feed some information, give some instructions to the LLM, and hope that it goes in the right direction, plays along with you. It's playing along with you. It doesn't necessarily know what you're doing, because again, they're not yet sentient, not yet. They're just doing a really good job of figuring out if this was a conversation, if this is some text, what's the next text that's going to follow on? We all know this, right? This is typical. Okay. This is the basis of all prompt engineering. I then want to set it up for a question. I've given it the idea of a role. I want it to be Yoda. Now here's my question. I've lost my marbles. Where are they? Some mornings, that's kind of how I wake up and the first thing that I think about. Playing along, Yoda says, lost your marbles. And then it gets a bit philosophical with its reply, because it doesn't really know yet where I'm going here. I haven't given it enough setup for what to do with this question that I've just asked it. So it gives a kind of generic answer that's like, okay, lost your marbles. Sometimes that means you're losing your mind. That's what the idiom is, of course. So it tries to play along with that a little bit, but it doesn't really lean into it. So it's actually doing a really good job with this response, I would say. But that's not enough. So if I actually want to get something useful, if I'm actually asking it, I've lost my marbles, can you help me find them? I haven't given it enough context to give that answer. It doesn't know who I am, where I am, anything about me. So I have to provide that context to the LLM in order for it to be able to answer the question. So I say, great, looking around the room, there's nothing on the floor, bag of marbles on the desk, there's a cat sitting on the windowsill. Just that things, observations. Here's the information that I know, pass it over to the LLM. Now it has some context, and it remembers that it was asked a question. It says, oh, wait a second. I noticed you said marbles. The marbles are on the desk. It's like, oh, the marbles are on the desk. I know where they are. It then gets a little bit indulgent, I guess I would say. It says, okay, you also mentioned the cat. So somehow it's going to engage in a little bit of conspiracy theory around cats and say, the cat watching, curious it is, stealing your marbles it has not. You can imagine it's thinking, not yet, because cats never know what they're going to do. But this is at least given it enough information so that it can answer the question that I was asked, that I asked, right? This is the foundation of retrieval augmented generation. All you're doing is providing enough, you're retrieving some information that's not available to the LLM, providing it to the LLM so that it can generate a better answer or a better completion to the text that you provided it, which is usually in the form of a question, ends with a question. So this is it. This is the foundation of all prompt engineering. Everything that we do in the software stack and the orchestration layer on the retrieval side into the database is all based on like, okay, can we find enough information and the right information so that the LLM, when given a question, it can answer that question properly. And there's a bunch of strategies involved with that. I'll talk through some of them coming up. Notice though, even with this small example, we already have some challenges. Like I was making fun a little bit about it, somehow incorporated the cat into its answer about where the marbles are. The cat's not relevant. Like, yes, I told you about the cat. It happened to be actually just right after listing, the marbles, fine. But the cat has nothing to do with where the marbles are. So why did you add that to the question? That already has to be tightened up. I probably shouldn't have provided that information because it's not relevant to the answer. So that's one of the challenges with prompt engineering, having not just enough context so that the LLM can figure out what the answer might be, but the right context so that it's highly focused on, here's probably where the answer is. I don't know what the answer quite is, but it's here somewhere for sure. use that for generating the answer, provide that back to the user. So that's our challenge. It then starts on the data side, on the retrieval side, with 3 different sources of data. And you have to think about those when you're doing the retrieval, because each of them have different access patterns, and you can combine them. And we'll walk through that. Where everyone starts, kind of the hello world of things, is you start with unstructured data. This is PDF documents, Word documents, whatever kind of documents you might have, HTML, media documents as well, depending on the model that you're working with. And you take this unstructured data that is, just data that doesn't necessarily have like keys and values and things in it, and you try to use that for doing retrieval, finding the right bits of documents, passing that to the LLM. This is great for doing basically information search. If somewhere within the text that you've got or the media that you've got is a match for the user's question, this is all you really need. This is perfect. If you're really just doing a very fuzzy lookup for the information, you can find that information, the thing that is most closely matching the user's question, hand that back, and then the LLM can generate an answer. So if you want to ask, like, what is Apple's primary business, and you happen to have a bunch of information about businesses, very likely that somewhere, Apple will state what their primary business is. That question will get a very nice hit. You'll bring that back, provide that to the LLM. Unstructured data. On the other opposite extreme, the data that we all know and love and have used for decades now, structured data. This is data in the form of records inside of a database somewhere. That also would be really nice to be able to ask questions about without having to, actually spin up a project and, have a team of people work on it. For some level of questions, a user who knows enough about the domain should be able to ask a reasonable question that can be asked of the database in a natural language and get an answer. That's kind of where we're at these days, trying to make that possible as well. This is the kind of thing, if it translates into a database query, you can ask database query type questions. And so if you knew something about Apple, you could say, all right, great, I have Apple's sales figures. I could say, how many iPhones did Apple sell in this quarter? That's a very databasey query to run, express that in natural language, but still be able to execute it. And you get real facts from the database, which, thinking all the way back to losing my marbles, those are going to have just the information necessary for actually figuring out what the quarterly sales are for the iPhone. In the middle, of course, there's all kinds of data sets that mix this up. We have a little bit of text, and you've got a little bit of data. This happens naturally if you're running any kind of a website. If you're running a WordPress website, you've got lots of long-form text, so that's the unstructured data. That unstructured data is also surrounded by a bunch of structured data about who the author was, what else they published, where they're from, things like that, what the users are, all the things that go into the application data. So you have a mix of structured data and unstructured data. That's another opportunity for doing a different kind of access pattern, different sets of access patterns, I guess I should say. This is perfect for actually doing things where it's more information discovery, where you're not precisely sure what the answer might be. It might be in a couple of different places, but because you've got structured data and unstructured data, you can kind of combine those in interesting ways to find the right information, whether it directly is reflected by the user's question or is just tangential to the user's question is actually where the answers are, where the full context is. So if you want to know things like, which investors will be impacted by a chip shortage, being impacted by a chip shortage is the kind of thing that might be reported in financial filings. So you'd be able to find that in the text. But the investors, that's actually structured data that's off somewhere else, where it's like, okay, here's the investor that's invested in a company who's exposed to a problem about chip supply. So then that's crossing over, you're doing a discovery from the unstructured data into the structured data for answering these kinds of questions. All of this stuff, eventually, in the way of data, might start off as like siloed, single point focused solutions. Over time, these things become connected and really become part of one overall question answering system. You start with one strategy, and over time, you stretch the boundaries of what can be answered with just that data. You end up adding more data, more context, different sources of data, and then you always end up basically in the middle. Might start on the left, you might start on the right. Everything ends up being a mix of structured and unstructured data. The technical patterns underneath this, how you actually implement this stuff, of course, for the unstructured data, fundamentally, people start with similarity search, doing vector embeddings. And a quick show of hands, we all know what vector embeddings are. Okay, some of us know what vector embeddings are. So for a quick review about vector embeddings, a vector embedding is the idea that, I'll step back for a second. So a vector, just think about that as being an array of floating point numbers. bunch of dimensions, just say, right? If you think about other things you can do with dimensional numbers, let's say you're in a Cartesian space and you just have X and Y coordinates, right? You can identify a point in space by its X and Y coordinate. You know if another point is near that by doing a bit of trigonometry, you just figure out what the distance is, right? And you can figure out how close 2 points in space are. That same idea basically applies if you can take anything and place it into any kind of a dimensional space. Here, that's a vector space. Once you've placed it into that space, other things that are in that space have a certain amount of distance. In practice, with GenAI, with doing RAG applications, that distance is really the similarity, the semantic similarity of the user's question, which turns into embedding. You place it into the vector space, into the dimensional space. The content, the documents that you've imported earlier on in the data preparation cycle are also placed into that data space. So because the documents are in the data space, the question gets placed into the data space. You can then figure out the proximity, how close the question is to text that was placed there. Find that text, bring that back and say, okay, this is the text that is most similar to the user's question. Hand that back to the LLM, hoping that the LLM will be able to look through the text and find a good answer. That's the quick summary. Happy to talk more about that if you guys have any questions later on, also later on in the day. I'm going to hop over to the right-hand side. The right-hand side is where you're basically doing take natural language and translate that into a database query. That works surprisingly well for very easy questions. There's enough examples of database queries out in the world. Database queries are so nicely structured, and LLMs are really good at doing pattern matching and pattern recognition, that even if you do what's called few-shot prompting, where you just do, here's some examples I've got, here's the user's question, and here's the kind of query I want you to write for that question. And you do maybe a couple dozen of those, or at least a couple to start with. If you just give it a little bit of hint about the kinds of queries you want it to write in the prompt that you give, so instead of saying, my marbles are on the desk, there's a cat on the window, you say, here's a bunch of examples of user questions and queries to write. LLMs are really pretty good at figuring out, oh, this user question looks like this thing. I'm going to try to write that query. You should never trust it to get it right. You should always assume it's wrong. Sanity check, make sure that the query that it generated is both syntactically correct. A little bit harder is knowing whether or not it's semantically correct, but definitely you should check to make sure that it's not doing anything damaging, that it's not a write query rather than a read query, because why not? It could very happily just change data, but you don't want it to do that. To do all the kind of easy rule-based checking on things, the hardest part is then running the query, and then you want to challenge the LLM saying, hey, given this user question, you wrote this query, I ran the query, here's the results. You want to ask it basically a question then before you give it back to the user. Say, hey, given this query, this question originally, and this answer that I've got here, here's the data that I've got. Does this data look like it probably matches the user's question? You want to do things like that to actually challenge the LLM's results, probably in all access patterns. You never trust it straight out of the bat. Okay, so that's the query side of things. Natural language turns into a database query. In the middle, you can mix these ideas. You can start with a similarity search, find me documents that are similar to this, but having found those documents do not live in isolation. Figure out either metadata that you have about that document, other information that's related to that document, to help improve the relevance of those documents and also re-rank them. So you might find things that look similar to the user's question, but they may not actually be the most useful in answering the user's question. So you might want to be able to grab extra information, make sure that, hey, and I'll go through an example later. One good point about this is that you might get documents that are really well matched for the user's question, but that are not authoritative. So you actually don't want to use those. So if you have that in structured data, and actually you're asking a question about, let's say, Apple's financial filings, you want Apple's opinion about that, not somebody else's opinion who in their financial filings mentioned Apple, and that they think Apple's biggest risk is Samsung, let's say, and maybe it is, actually, I don't know. But you don't want somebody else's opinion, you want the authoritative answer on that as well. So structured data gives you the opportunity to do that. So whenever possible, this is how you improve your answers, is by not just relying on similarity search, but being able to qualify those results, both in terms of are they relevant, and then also rank them a little bit so that you bubble up the ones that are most relevant to the particular user. All kind of strategies apply there. That's the general idea. And I'm happy to chat more about any of this later on in person. Okay, I'm going to now walk through an example. This is, and I apologize for the data set. This is from the US. I was raised in the States, and so that's what I'm most familiar with. There's this financial data set you can get from the FEC, that's the SEC, I should say, sorry, the Securities and Exchange Commission. That is the government body in the US that regulates anybody who's publicly traded. So if you're a big company and you're on NASDAQ, and you've got to file with the government saying, hey, here's our current business, here's our current risk to the business, those kinds of things. That filing, here's our business and here how things are going, so that investors can know, is called Form 10-Ks. So that's a great source of unstructured data. Lots of prose, a lot of paragraphs written about the company's business. On the flip side, for investors of a certain size, so if you're an investment management company, and I think it's something like 10 million, I don't actually know what the threshold is, something like that. If you're investing a lot of money into publicly traded companies, you also have to file. Let the government know and let everybody else know who you're investing in, because that matters as well, because you might influence the market. So the Form 13s would get filed there. I don't really care about the investment company's investment strategy. What I care about is where have they placed their money and how much money have they placed into what companies. So that ends up being structured data about the unstructured data. Okay, that's what we're going to walk through. Here's the data modeling strategy. For me, this is a data modeling strategy that is graph-based. This is the way that I think about things because I work for Neo4j. We're a graph database company. And so I think in terms of how are things connected. Here's how I approach doing that for this data set. For all data sets, actually, this is true. I start with the smallest amount of data that is useful. So just create some data, enhance that data somehow. This is the usual thing we do with databases. Is it helpful to have an index here? Great, let's add an index. It might be a vector index, so you can do vector similarity search. Use that. And then the third step, for me, is really critical because it's surprisingly powerful, is that data actually isolated, or is there a connection that I can make to other data? Because whenever that's true, in this setting, you get better results. You can get better context and better refinement to those results. Okay, with the Form 10-Ks, that starts with the unstructured data and doing what's called text chunking. Chunking is just splitting the text somehow. There could be an entire session just dedicated to this chunking. If you guys haven't tried it, it starts off really easy. You just want to grab, 2,000 characters and just split. 2,000 characters and split. And then you get lots of nice chunks of text. If what your intent is to have chunks that match users' questions, that's not a great strategy. You're getting arbitrary chunks of text. You want to get close as you can to chunks of text that are likely to be matched for users' questions, because that's what your ultimate goal is here. So chunking itself is already a problem. I'm going to ignore that problem today other than say that's a problem. Chunk it up, create a bunch of data records here called chunk records. For each of those chunk records, calculate a vector embedding. So go ahead and get that array of floating point numbers. Save those numbers on the records themselves so that every data record has the text, metadata about the text, and also the vector embedding value. So the vector, right? And then for my third step, because I know that these all came from an original document, I want to maintain the fact that they are actually in order. So turn it into a linked list so that whenever I find any given chunk, if I want to have a context window, I can then go in and out of the chunk to actually find out extra information around that if the original chunk wasn't enough information. Okay, so this is my initial minimum viable graph for creating something useful for actually answering any questions about financial information in the US. All I've done is create a linked list of text, created an embedding for the text that's on each of those records and saved that as well. I can already do lots of great things. If, as I said earlier, if you're just asking what's Apple's primary business, that's a great question to be answered directly from the structured data, unstructured data. So that's good. We can now improve this already a little bit without even being too creative. Because we know this all came from a document, a useful strategy is depending on the structure of the document, at different levels, you might actually create a hierarchy that represents the original structure of the document. From the document itself down to the chunks, there might be sections, there might be chapters, depends on where you've actually started. For us, all we've done is go up one step just from the document directly down to the chunks. You can do this, again, as multiple levels. You do this for a couple of reasons. One is that all of the metadata about where the chunks came from doesn't have to be replicated across all the chunks. Just put that into the document itself. This document came from Apple whatever their information is, whatever you want to put there, put that there. It also gives you the opportunity for generating a synthesized summary of the text, of the, that hierarchy, part of the hierarchy. So generating a synthesized text, the advantage there is synthesis. If you're going to ask the LLM, hey, give me a summary of all this text, you then have another thing to ask questions about, because the summary might actually have a closer match to a user's question than individual chunks do. So this already is a very useful strategy for improving results you get and broadening the kinds of questions that can be answered. Because the original text may not have an answer, but the summary might. And again, you can do this on multiple levels. So go ahead and create that, create the summary, generating it, recognizing that it's synthesized, maybe handling that a little bit differently because you want to curate that. But then also doing the embedding and allowing that to be used for question answering. Okay, over on the structured side of the data, this is coming from the 413s again. This is from the people who are investing in the public companies. And this is really just pretty straightforward. CSV file, in the CSV file, pull out for every investment company, who do they invest in and how much do they invest? So I end up, in the graph, it looks like this. You've got some manager for the management company that owns stock in some publicly traded company. Import all of that, and that's pretty easy. You guys are all familiar with relational databases, right? Okay. The way to think about this own stock in, for a graph database, that's just a data structure that goes directly from record to record. But in a relational database, you put that in a join table, right? So it's as if you have pre-calculated all the joins, and you actually have data structures that materialize them, which makes it very fast to do graph-type things. That's why we do it that way. And a quick aside about graphs, the whole reason for doing that kind of thing, it's when you shift from worrying about queries that are about aggregate information versus individual record information, which in the context of the AI is really important because you care more about the context than you care about the summaries most of the time. So if everybody in this room was in a relational database, you could ask a question like, how many people are in this room? Great question. How do you know me? Or who's most likely to buy me a beer? That's a graph question. That is not a relational database question. Very hard to answer with a relational database. Very easy with a graph. Okay, so we go ahead and create this stuff, we put it into the graph. Now we can do structured queries against this. We can generate from natural language queries against this and find things out. That's really nice. Notice, by the way, that I added full text indexes here, not vector similarity search for this, because I want text difference. I want to allow for typing mistakes or different spellings rather than similarity in concept when looking up company names on either side of this. Thinking about indexes and the different kind of indexes you want to end up using, it's the usual things. Geospatial is also relevant. Sometimes you care about investment companies near you or restaurants typically near you, for me when you're traveling. So go ahead and we have information about that for all these companies, create addresses for that, do a geospatial index on that, and now you can ask geospatial index-based questions like how many businesses, how many management companies invest in companies that are geographically near them. Now you can answer that, right? Because you've got all that information on hand. To combine all this stuff, then the easy thing to do is take for each of those companies on the structured side, connect them to the unstructured form that they filled out. Now you've got kind of the complete graph. This lets you then do the mixed queries that I was talking about before. You might start with the vector search and then find some structured data around it to improve the context of that. Or you might start with a structured query and reach into the unstructured stuff. So you might say, actually, what is Apple's, what's the summary of Apple's business? It might be easier and actually quicker to just go, oh, okay, I know what that question is. You just go from Apple to the first section and return actually just where you know the answer is, return that. Don't actually try to find similarity for that. This is what I ran through, a bit quickly, but so this is the steps of the entire database that I created. From left to right, all I've done is gone from creating some chunks, doing the text splitting. For each of those chunks, create the embeddings. For each of the chunks, I then said, okay, let's actually represent the original form itself, do a summarization on the form, connect that form to the company and the structured data, where the company is also connected to a management company, and then where both of those companies have addresses, and then wire all that stuff up. This kind of process of elaborating should, of course, be driven by user questions. If people aren't asking questions about this stuff, don't bother. Start and focus on as little as you can about the data. Because I promise you, again, all the way back on the chunking side, you'll spend a lot of time just getting that right. So don't boil the ocean, don't solve everything at once. Focus on a little bit at a time, get that right, make sure that the quality of your answers are great, and then add information as you're finding boundaries where people are asking things you can't answer. So that's something I want to say up front. And yet, having said that, this process can continue. You continue to add extra information that people want to know about, continue to connect them together, add information about the user themselves, keep a memory of all of the interactions so the next time they come back, you know the things that they're interested in, and you can factor that into the prompt that you set up. So you're like, okay, this user who cares a lot about ... asked a question about ... factor all of that in. Thinking all the way back to the Yoda prompting at the beginning with the cat and the marbles, get that if the marbles and the cat actually are relevant, and that keeps coming up for a user, save the user some time. Provide the context from the user's memory. So that ends up being great for user experience because then users, because ultimately we're still building applications for end users, right? Don't forget that users care, they want to be remembered, they want to have continuity of their experience. So preserving the memory helps get better, relevant questions for them, better relevant answers for their questions. Okay, and so there's all that. In a little bit of an elaboration here, this ends up down the path of GraphRag. GraphRag broadly is this, starting from small, easy to answer questions, and then elaborating on, okay, well, what else can we do here to massage the data, transform the data, extract things from the data, add extra things to answer more complex questions, broader questions, things like that. This particular diagram, I've done a couple things. I've taken the original, the structured data on the kind of cyan and green, the unstructured, the form, the chunk, the yellow stuff over there. I've added the bright green up there, the community and the entities. That is a popular thing to do early on. You look through the text and you do natural language processing to extract entities, right? So named entity recognition. Tell me the people, places, and things that are there. That's already pretty nice because you can extract useful things about like, what's this really about? And you can see across chunks, what are the common things that pop up all the time. You can do things like, I don't know, centrality, queries on that. You can do some analysis basically on that. That's really nice. But the other thing you can do, and this is, kind of thinking about like the hierarchy of summaries that I talked about, you can do a summary of that as well. You say, oh, okay, it looks like there's a lot of entities that are very similar. They form a community, do a bit of community detection for the data scientists out there, right? Figure out the communities of entities that have been extracted, and for each of those communities, generate a summary. Say, okay, for each of these communities, let me find the text where those communities were mentioned, generate a summary for that. When you do that, you end up with basically topical-based summarization across the document text, which doesn't exist in the original text other than implicitly. As a human reader, when you've gone through, you might come away with that. You might realize what the themes were, what keeps coming back. You will have taken that away from reading some text. The LLM does not naturally do that because it hasn't seen the entire text, and it hasn't been motivated to actually do summarization of the text. So you go ahead and basically pre-calculate that. Say, okay, let's anticipate that users might ask broader questions, figure out the communities of things that occur within the text, generate a summary, do a vector embedding on that. And you can do that at a couple different levels as well, similar to taking the structure of the document and doing summaries there. Okay, so there's all that. I think I'm still under time. Am I doing it? Oh my gosh, you had a 10-minute sign for me? Okay, I'm going to keep talking. No, okay. Okay, so that is the need of my presentation today. I'm happy to take some questions. Please.
If the prompt is something complex, like JSON or aspects are, so this could be personal ID, which the complex.
Yeah.
Would you preference to retract these structures on JSON or YAML, or would you prefer to both be used to track which would be too complex and graphite or too complex? How do you think, what would you consider?
So if you could tell me if this is fair for restating that. Like, so basically, if you already have some structured data, right? It's JSON, I think you're saying? YAML JSON or whatever it is that you're ingesting. If you already have basically structured data, it'd be hard to turn that. I mean, it's not impossible. You could turn that basically into text and then do text embeddings on that. But it's structured data. Just import the structured data as it is and think more in terms of the mapping from the natural language into a query that actually finds that stuff. And there are some of these techniques that I talked about, like here I was focusing a little bit on unstructured data and how to use the LLM for even doing like named entity recognition. Something I didn't mention that is relevant for this is don't ignore the known identifiers, even if you have unstructured data, right? If you know there's going to be URLs, there's going to be IDs that you already know the format of, do regex. Find those things, connect those things. Do not, a little anecdote here, like I had a colleague who, and this is early on, we're experimenting. Like, oh, I've got a bunch of XML data. Let me just feed that to the LLM and have it pull out all of the relevant text. Awesome, easy. I don't have to do any of this, XSLT, whatever nonsense. Like, I don't have to do it. It was a nightmare. It was a complete mess because the LLM doesn't know what to do with that stuff. And XML is a solved problem. Yeah, it's not fun. We don't like to deal with it. Fine. But it's a well-known problem. It's a very predictable answer if you actually just digest the text. So don't degrade structured data into unstructured data to try to take advantage of an LLM. Do look for the textual bits within the structured data, calculate an embedding for that. So just take it exactly as is. So if it's YAML or whatever, you're probably going to end up with like things like names, do a full text index on that. If you're going to have descriptions and things, okay, that's a good candidate for a vector embedding.
Cool. Sorry. I was thinking when you're comparing two documents, so if you want to compare two different structures of JSON and a YAML, let's say, and say, think of domain-driven design, where you've got domain boundaries and you might have a similar customer ID on that side and a customer ID in a sales and a product scope, the document's going to be radically different. So getting the context between the two, the human can do quite easily and say, oh, that's a customer ID, that's a person ID, they're the same thing. That's why you might have the mixture between the two. So.
Yeah, if we're trying to find the similarities between two different documents, different shares. Yeah, that's interesting. So, okay, now I'm going to retract what I said a little bit because we actually do a little bit of that when we're doing data import into our database, like some of the libraries we've got, because you've got to come up with tables, you've got to come up with table names and things. And so it's actually not bad to turn to the LLM at that point. It is still helpful when you do that, and when we do that, we start with basically a schema, here's some things we anticipate. Can you find these things? If you leave it open-ended, it's usually not very successful. But if you constrain it a little bit, here's the things to anticipate to find, can you find these things? I think that's a better bet.
Nice.
Yeah, if that makes sense.
Cool. Cheers.
Other questions? In the back. You're going to get some exercise. Go, go, go. Come on! You've got this!
My question is, you talked about the happy path. What happens if you realize that the data you feed them into your model is bad data? What do you do?
Well, so that's why you do data curation. And certainly through all these processes, I guess you're right, what I did mention is it's important not only to start with a small data model as possible to answer users' questions, you start with a small volume of that as well, and spend a lot of time setting up an eval process so that as you develop a set of questions, and for that set of questions, you have good answers. You decide what comes back as a good answer and what not. And as you change your system, continue to test it basically and figure out, is this still good or not? And if the data that you have is already bad, through that process, you should end up figuring out that the data itself is bad. And if the data that comes back from the questions that are, while it's in production, if that comes back and you realize, you don't yet realize that it's bad and you're about to hand that to the LLM, that's not a great idea. On the orchestration layer, you basically want to end up having this kind of challenging section here, this adversarial LLM process. And typically you want to use a different LLM for this. So you let one LLM do one part of the process, use another LLM for kind of evaluating the output of the RAG. So here's what I think the prompt is that we hand back to generate an answer. Before you do that, you hand that to another LLM saying, hey, given this user question, here's what I'm going to provide for an answer. Does this look right to you or not? At least something like that makes sense to have in the flow. Does that make sense?
Good.
Cheers. Other questions? Please.
When you talk about RAG and memory, are they more or less the same thing? Or how's memory different to RAG? Does that not make sense, that question?
I mean, it's a great question because they're talked about as if they are different and because they are practically different in one particular way. So if I go all the way back to here, actually, we'll go to here. It is the same thing. You're just doing retrieval augmented generation with the memory that is nicest thing you can do for users to provide for all the sessions that they've ever had, structured memory around what they've actually asked about before. You can already do some of the things I talked about with the data sources, PDFs or whatever. If a user entered a bunch of things, they've had a bunch of chats, you can figure out what are the themes of those chats. What are they talking about all the time? You start to build up some knowledge about that user, some context about them. So that's the memory part. It ends up being structured a little bit differently because it's attached to a user. So it's not just global knowledge, I guess, right? It's particular to user. But the process is the same. All you're doing is, for this given session, for this given user, let me get the context that is going to be relevant for answering a question that just came up. And so the cat, for me, might end up popping up all the time. And so, okay, put that into memory so I don't say, oh yeah, I forgot to tell you about a cat. But it's still part of the same process. It's a different source of the data, but it's still, you're retrieving some data from somewhere else, ultimately adding it to a prompt, and that's the full context. When you do this with the LLM, I guess I didn't show this, with the retrieval part, the output of the retrieval is really two things, or three things maybe. Here's the data that you've retrieved from data source. It might be memory, it might be a database, it might be the internet for that matter. Find all the things you think are relevant, package that all up into prose, write some sentences, hand that in the context of some instructions to the LLM. Hey, LLM, talk like Yoda, whatever else you want to tell it. So there's that component, tell the LLM what you want to do, give it context for what it should do. And then the last part is, oh, and by the way, here's a question about all the stuff I just told you. So you set and it gets down more complicated than that on the prompt engineering side. But so whether it's memory or retrieval from a database, ultimately it ends up being fed into that context and stuff into a prompt. Does that make sense? Okay. Cool. Cheers.
Time for one more question.
Okay.
5 minutes.
Yep.
Hi. My question was about constantly evolving data sets. So if you're adding stuff to it, for example, CVs from people, and you want to constantly kind of add, if someone brings in an extra CV, you want to kind of recalculate all of that stuff. Does Graph work for that, or do you need to kind of recalculate the whole thing every time somebody adds something to it, or is it easy enough to kind of tag on?
Yeah, that's a great question. So it is accumulative, so you don't have to do it all at once. In fact, when you do the data preparation, the data ingest at the first point, really that is done document by document anyway. So it's just like you're adding another document later on in time, doesn't matter. You're still going through the same process on a document basis, chunking it up, doing the entity extraction, doing community detection on that. So some things that might change are like, if you've done community summarization, you might have to re-summarize if the community has been affected. So you do want to recalculate the communities, and that's cheaper, I should say, than doing the summarization. Just figure out, okay, is this community the same or not? And if it is, then recalculate. So it's a little bit like doing cache management at that point. Like, okay, is this now stale? So yeah, that's probably a good analogy, actually. Does that make sense? Yeah.
Maybe time for one more, since there was a quick one. Anyone else?
Right.
Oh, really? Hi there. You mentioned putting the results back into the same model and asking if it was okay. Is that all right to do, or is it just going to say, yeah, it's great?
Yeah, so it turns out like a little bit like I was showing here with the kind of toy Yoda example. The more instructions you give to a model, it complies with those instructions really well. So even if you just question it, say, hey, you just told me, you think something's wrong with the cat, or the cat's curious. Is that really true? It might be like, well, actually, no. I was just kind of making that up. So even if you use the same LLM, challenge it, that works. That is effective. I do, though, recommend using a different LLM for actually doing the evaluation, because there might be some built-in bias where it thinks like, yeah, to me, that looks really great. Some other LLM might be like, yeah, you know what? I don't believe you. And also those kinds of LLMs, you can tune them as well for doing challenging. So we didn't get into doing any fine-tuning. In general, if you just use ChatGPT, the latest model that's available, it's going to do a good job at kind of everything. The downside is it's super expensive. And so you very quickly, as you get into production, want to find specialized models as small as you can find for different parts of the task. You'll end up having multiple roles that the LLM plays in the orchestration.
Thank you.
Cool.
So shall let everyone know that after every talk, the speakers will be at the speaker collaboration zone, and that is by reception, so you can go and ask questions. I guess you'll hover around there for, I don't know, how many minutes, or well, about 10 minutes or 20?
12 minutes.
12 minutes, exactly, so you can hold my gas to. So Andreas, any final thoughts, CTAs, plugs that you want to share?
Yeah, so I will say actually, just as my final thoughts is, this is, even though we're, what, I don't know, a year and a half or so, like we're into GenAI, this is a fast-moving space. There's a lot to keep up with. Don't worry about keeping up with everything. Actually, the basics are pretty well known right now. Feel confident that everybody is experimenting. The reason there's a lot of change is people are still trying to figure stuff out. So don't feel like, oh my God, I'm not keeping up with the latest papers. Don't worry about it. You can do this. You can start with the simple prompt engineering. You can get as deep into it as you want to. Don't worry about that. If you want to learn more, so again, we're Neo4j, we're a graph database company. I'm happy to come back out here to Manchester to chat. If you guys have more events out here, that'd be great to talk to people some more. Or if you happen to be down in Cambridge, look me up. All right, thanks.
Thank you, Andreas.